Right then, the higher course, chapter 24, the last set of videos. As you can see, I've got a nice little theme up there, a smiley, happy, sunny face. That's me, except I'm really tired, really not in the mood for smiling. So let's look at this chapter then. It's all about transforming graphs. Now, you've done transforming shapes before. You can, for example, reflect a shape, doink, like that. You can translate it across the place like that using a vector. You can rotate. Well, you can do similar things to graphs as well, but we're only going to do limited transformations of graphs, not every single way of transforming. We just do some of the rules that you need to know. Now, what I've got here is a spreadsheet. In fact, I'll produce these results with a spreadsheet. Here are some x values from -6 up to 6, and this is basically, so this little set of results here is y equals x squared. As you can see, -6 squared is 36 and 6 squared is 36, etc. And this one is meant to simulate y equals x squared plus 4. So here I go. Let's call that y equals x squared plus 4. And this one is y is x squared minus 3. So this set of results, when plotted by the spreadsheet, will give me a graph of y equals x squared minus 3. Let's put a nice little ring around each one. So y equals x squared. I'm going to compare that with y equals x squared plus 4 and y equals x squared minus 3. Now on the other page, I've got the Excel document to print off a scatter diagram, and this is what it produced for us. Alright, there it is. Now let's identify each one of these little graphs. Now if I look at this one here, I've got the point 0, 0. So 0 times 0 is 0. 2 squared is 4, so that probably reads as 4 there. 3 is about here, and 3 squared is about 9. So I reckon I've identified this one here as y equals x squared. Now look at this one here. I think that one's going to be y equals x squared plus 4. But just go back a page, and there it is. Y equals x squared plus 4 is this purpley one here. And this last one dips to, I think, minus 3. Let's just check it. Yeah, y equals x squared minus 3. Quite hard to tell because the software doesn't label 1 unit for each number. So no worries. So y equals x squared minus 3. Now let's just study these. Well, there's y equals x squared passing through 0, 0. And here is y equals x squared plus 4 passing through the key point there of 0, 4. And the red one is y equals x squared minus 3. So it's passing through the point 0, minus 3. Very sensible, very straightforward. So this kind of transformation, where graphs move up and down the y-axis, are very easy to spot and identify. So in very general terms then, if we have a function, any random equation like y equals something to do with x, okay, this is the most generic equation going, y equals some function of x. As soon as I come across and go y equals some function of x plus something, plus a, there it is there, then the graph is shifted upwards a units or downwards a units, should that be a negative value. So this one, for example, y equals fx plus a, moves the graph upwards by the value of a, in this case plus 4. Or we can use it in this form, y equals fx minus a, where of course the graph goes down by a units. Let's make that look a bit more like an a and not like a 9, and we'll regroup. So function of x, take away something, and that shifts the graph down. In this case, the minus x would correspond to the minus 3, and that shifts the graph 3 units down the y-axis, and all the points just follow it down, you see, because every point is shifted 3 units down, whereas with a purple one, all the points are shifted 4 units up. Alright, so we can consider this as a transformation using a vector. If I try and find a purple colour here, then it will sort of match nicely if I go for that purpley arrangement there. So this graph here has moved 4 units in the y direction. Y equals x squared plus 4. So we can say it's been transformed using the vector 4, 0. So not 4, 0, 0, 4. We're going nothing along and 4 up. So that's going to be 0, 4, okay? So that sort of moves it upwards. And this little red one here, I'll stick to that red there. If I look at this very carefully, it's dropped 3 units from 0 to -3, so I've gone 0, -3. Alright, so these graphs can be described as being transformed using vectors that you know about from previous chapters, and it's 0, 4 in the upward direction, 0, -3 in the downward direction. That is the first rule we need to know, and there's about 6 of these things. Some are really complicated, others are really easy to understand and explain. Okay, so up and down movement. The general equation, y equals some sort of function of x. I can move it up, y equals fx plus a, or I can shift it down, y equals fx minus a, and the a number will tell you how many units up or down you shift the graph. Alright, and they can be described as vectors. Let's try and get one more into this introductory video. Here I go again. What I've got here is more equations. Y equals x squared. Remember, this is going to be my basic f of x, my basic function against which I compare all my other transformations. So that's the basic y equals x squared one. Here I've got y equals x minus 2 squared. Okay, y equals open bracket x, take away 2, and then square it. Alright. This one is y equals x plus 2 and then square it. So y equals open bracket x plus 2 and then square it. So these are my 3 graphs. Y equals x squared, y equals x minus 2 and then squared, and finally y equals open bracket x plus 2 and then square the whole thing. Alright, let's see that in fact does work. Let's just test 4 for example. Well, 4 take away 2 is 2, and 2 squared is 4. That works. Try it over here now for y equals x plus 2 squared, using x values there. 4 plus 2 is 6, and 6 squared is 36. So the software got it right, and so I trust that when I flick over to the other page, the graphs are right as well. Right, let's try and identify what's going on. Well, this graph here is clearly y equals x squared. Let's just test it. 2 squared is about 4, yep. 3 squared is about 9, that's good. 4 squared is about 16, that's about right. So I'm pretty sure this is meant to be y equals x squared. Now, this is the horrific bit. These are the general equations, or rather the general transformations. Again, I'm still playing with the generic y equals something to do with x. And if I've got this one here, y equals bracket x plus something, and here I've got y equals f bracket x minus something, it's what these somethings do. Now, let's look at it very carefully. This is the graph of y equals x minus 2 squared. Look at the coordinates where it bumps along the x-axis. When x is 0, y is 4. Let's just test that one. When x is 0, y is 4. So I've got a choice of 2 now. So that's not going to help me to identify it. Let's go back one more page and try and do this. When x is 2, the x minus 2 squared graph lands on 0. So I've got the point 2, 0. And that is for x minus 2 squared. So I'm trying to convince you that this graph is actually y equals x minus 2 squared. It's horrific, isn't it? Because look, it doesn't cross on minus 2 like you might expect. It actually dips at the coordinate 0 plus 2. Alright? And yet the equation is y equals x minus 2. In a similar way then, this red one, where it troughs at minus 2, 0, is actually the equation of y equals open bracket x plus 2 squared. Sorry, I didn't say squared then. That's what I meant. And let's study this red one carefully. I'm looking for the coordinate minus 2, 0. Alright, so x is minus 2, and there it is, 0. Right? There's the 0, there's the x is minus 2. And the coordinate minus 2, 0 belongs to this graph, in other words, the x plus 2 squared graph. So there's no mistake in the drawing or the labelling of these graphs. Alright, so what have we got? It seems that if I have an equation y equals x minus 2 squared, it shifts to the right by 2 units. Even though it says minus 2. And it seems that if I've got the graph of y equals x plus 2 squared, it shifts to the left 2 units, which is quite hard to get your brain round, but if you look at the coordinates and study each point in your own time, you'll see that the graphs are actually correct. So what do we get here? If I look at this, if I draw this a little bit larger, we have with this function y equals function of x plus a. What it does is to move the graph this way by a units. Alright? It shifts the graph to the left by however big a is. In this case, y equals x plus 2, and therefore the graph will shift to the left by 2 units when comparing it with the original f of x, y equals x squared. Similarly with this one here, y equals function bracket x minus a, it moves the whole graph to the right by a units. In terms of real numbers and real equations and real graphs, this one here, x plus 2, doesn't move it to the right 2 units, it actually moves to the left by 2 units. As you can see by the coordinates minus 2, 0, look, moves left 2 units compared to the original y equals x squared. So what can we say then? When we have the transformation y equals f bracket x plus a, it moves to the left a units, and as a vector we want to go let's have a look, let's use real numbers now. So you look at the red one then, it's gone to the left by 2 units, therefore it's been transformed using the vector minus 2, 0, again starting from 0, 0, going to minus 2, 0, that's the movement of the graph using vector minus 2, 0. And here we can see the purple graph there moves from the point 0, 0 in y equals x squared and becomes a trough at 2, 0. So therefore the vector that transforms y equals x squared into y equals x minus 2 squared is simply 2 along, 0 up. Alright? So really these two functions here express the movement of any function or graph left or right along the x-axis, whereas before initially we have a movement up and down the y-axis. Okay, there is a difference, they're easy to spot. Up and down looks an awful lot more different to left to right. Okay, so that's 2 transformations. I may well leave it there and come and do a couple more. This is really complicated, it's A star, there's nothing grade A about this whatsoever, just getting your head around it is a pain. Okay, quick reiteration, because I need to get it straight in my head again after all these years. We can move up or down by A units, up or minus A units takes us down, and the graph transformation can be described using vectors 0, 4, in other words go up by 4 units, or 0, minus 3, drop the graph down by 3 units. This lot here, what have we got? Y equals function of x plus a, move it to the left a units, in other words minus 2, 0 in this case, and the function y equals f of x minus a, move it to the right by a units, in this case, you know, shown by the purple graph here, y equals x minus 2 squared, we move it to the right by 2 units, in other words 2, 0. And that's all I want to say for now, and I'm going to try and keep smiling through this really tough topic. I hope you can, because the end is in sight. So I'll see you for the next little part quite soon.